Hey, good morning, everyone. Morning, REcon family. How do I follow Ice Ice Baby? It was a great talk. Only thing I can think of is stop, collaborate, and listen. That's all I have. Before I begin, I just want to say this is my probably 10th year coming to REcon, first year presenting. So happy to be here talking to all of you. So let's begin. Hello, 1994. Surveying the room, probably older than most of you here today. Abusing Windows Explorer via Component Object Model, aka COM, in 2023. So who am I? Luckily, I have Windows, and I type who am I/all. It tells me my name, Mike Harbison. I've been with Palo Alto Networks, Unit 42 Threat Intel, 6.5 years. Prior to that, I worked at DC3 as a forensic examiner. I also worked at Mandiant, pre-acquisition. I was a vulnerability researcher, and I've been doing reverse engineering since this tool. I'm going to date myself here, known as Soft Ice. Numeric Soft Ice. Trust me, for those who know, it's an older tool, and I've been in this game for a while now. So what is today's agenda? I promise you it's not going to be a threat intel talk. I know we're all reverse engineers, but I think it's important that I give you some foundations of where this research came from. So I'm going to talk about the PlugX malware, overview of COM, the USB infection techniques that this sample uses, Microsoft's response to this research, and some time for Q&A. I love questions. If you don't get to me to answer them up here, please find me in the hall, stop me, introduce yourself, and you'll most likely find me at the bar. So what is PlugX? To nobody's surprise, PlugX is malware. It's a fully featured remote access tool, primarily targets Windows operating systems, first seen in 2008, so 15 years. To nobody's surprise, it has a Chinese nexus, but it has since been adapted by several different nation-state actors. It's historically been written in C and C++. It abuses trusted software, like your printer software, your AV software, to sideload some encrypted payload on disk. It is considered one of the oldest and evolving malware families that are out there. If you look at the stuff that's going on with China and Taiwan right now, you're seeing PlugX being used. It's still the go-to tool by these nation-state actors. So this became personal to me when I saw this. For those who can recognize x32debug.exe, that is our beloved x64 debug program. So the actors here were abusing our reverse engineering tool on target. In this case, the actor's DLL, x32bridge.dll, is just responsible for loading x32bridge.dat in memory. So it decrypts it, loads it in memory, and it's nothing more than a DLL. So that was what we saw here for the chain of events here. So, journey into the I unknown. For those who don't know, I unknown is a pun to COM. I unknown is the base interface for all COM interfaces. And this is our discovery timeline here. It's a little backwards. So in January of 2023 of this year, we discovered this x32bridge.dat while investigating a Black Basta ransomware case. It's not uncommon for us to find multiple threat actors deploying different tools. In this case, you have Black Basta using PlugX. So then we turn to one of our favorite tools, that being VirusTotal, to give us any historical information. Do they know about this file? Turns out VirusTotal had a copy of it in 2021. It was uploaded from somebody in Thailand. At that time, only 4 of the 60 AV engines said it's malware. When you peel back that DAT file, like I said, it's nothing more than an in-memory DLL. If you look at the PE date and time, it tells us when the file was linked. So 2019, it was built. So pretty much between that time and uploaded to VT, it remained undetected. I should also point out that none of the talk about the USB component was ever talked about until my research was published. This particular USB infection of this malware targets all type 2 devices, drive removable. So those are your little thumb drives, for those who don't know. It implements 2 versions of COM, so 2 COM objects to achieve its goal, one being the shortcut, the next being the recycle bin. And this is the important part. The use of a Unicode character non-breaking space, or NBSP for short, to conceal itself, basically to trick or to hide itself from users. But the combination of the NBSP plus the recycler bin folder prevents the Windows OS, even to Windows 11, from navigating into that directory. So you as a user could not change into this directory either via the command console or File Explorer, even with today's Windows 11. So I said there was 2 COM objects used. So what is COM? Well, as we know, Microsoft has some great definitions. COM is a platform-independent, distributed, object-oriented system for creating binary software components that can interact. COM is the foundation technology for Microsoft OLE, object linking and embedding, compound documents, and ActiveX internet-based components technologies. Now you all know COM. In simple terms, it allows multiple software applications to interact. It's been around for 30-some years. I can't believe I'm here talking to you all today. I remember programming ActiveX controls back in the day for Internet Explorer using COM. It's pretty much considered obsolete when .NET and WCF were around, but it's still being leveraged today. It's on all Windows operating systems. And it works by using these 128-bit class IDs, GUIDs. They're unique. They point to different objects that are available and exposed to you. And you can find all these in your registry. So I'm all about showcasing how this thing works visually. After last night's cocktail, I think this would be helpful. So on the root of your USB device, that small thumb drive, you will have the very first NBSP directory and a Windows shortcut. The Windows shortcut does nothing but point to x32 debug. The NBSP directory on the root will have a hidden attribute set and directory set. So it's hidden from the user. All user files are moved to a second NBSP folder on the root of the USB device. So within that NBSP directory, you'll have another NBSP directory, another shortcut, again going to x32 debug. Maybe they believe 2 is 1, 1 is none. They want to pretty much guarantee if a user were to click that shortcut, it would execute their code. And what's most importantly here is this desktop.ini. For those who don't know, in Windows Explorer, if you have a directory set is hidden, Windows Explorer will look for an associated desktop.ini to apply the properties to that hidden folder. In this case, they're using shell32 number 7, and then that is that blue image that is there. So they're basically turning that folder or directory to appear as a drive and not a folder or directory. In that NBSP, in the second NBSP directory, all the user files and folders would be moved here. Now, in that directory, they create something called recycler with the r.bin directory. Notice the slide of I, notice the R, because on a Windows machine, it's called recycle.bin. Here, they have another desktop.ini, again, turning that NBSP directory into what appears as a drive. Within the recycler bin directory, they'll create another directory called files, and here they create another desktop.ini. For those who ever wondered, how do I create a recycle bin on a USB device? It's quite simple. Create a directory, set its attributes to hidden, and as a directory, create a desktop.ini, put the COM class ID of the recycler bin, and Windows Explorer will now treat that directory that you created as a recycle bin. So now if you ever click on that, it will take you to the master recycle bin, and the file directory that was created under is no longer accessible or viewable. As I said before, this thing uses 2 COM class factories, one being the shortcut and the other being the class ID, recycle bin, sorry. And these are the 2 corresponding class ID or RIDs, and these are unique. And once you instantiate to, like, let's say the shortcut, these are the different interfaces that are exposed to you. And you would use co-create interface, whatever programming language you want to use. And you can see the last one is the I unknown, as I mentioned earlier. That is the base interface for all COM objects. And this is for the recycle bin. So how does this malware use that shortcut COM object? You first create an instance to it. Once you instantiated that instance, then you have these different methods. So the first one being set path. You set your path to x32 debug in this case. You set any arguments that may be required to run that executable. Most importantly, you set show no active. You don't want anything blinking to the screen. You set the icon. Here, they're turning the link file, that shortcut file, they want it to appear as a drive as well. Again, to the user, they see a drive and not a shortcut. And finally, once you made all those changes to your object, you just call iPersistSave, and you save the object to disk, and like that, you have now a link file with all those properties set. And using our favorite, my favorite, WinDebug or WinDBG or WinBag, however you want to call it, you can see here, or in yellow, the shell, the first box up there is shell link calling set arguments. I'm able to dump that, and you can see here the circled in yellow is the NBSP directories, and then the path. So /q/c recycler.bin files x32 debug is what's being passed as the arguments to this object. And if you were to look at this on properties and viewing it, you would see compspec being used, x32 bug being called, compspec being the command variable. So here, it's doing nothing more than launching command.exe, don't echo any of the commands, run and terminate, and call x32 debug. Nothing fancy. Can you spot the NBSP? Can you see it in there? Is it, I mean, if you were to look at this on disk, would you see anything wrong? I mean, besides running x32 debug, but you clearly see it's running from a recycler bin /files, and you don't see those NBSP, they are right there. So, what is the significance? I've been talking about this NBSP directory, is A000. Basically, this directory in combination of the recycler bin prevents Windows, it's the white space, from rendering the directory name, making the folder invisible rather than leaving a nameless folder in Windows Explorer. I confirmed this behavior with Microsoft, and they agreed that it is an issue. Now, I should point out, if you didn't use the NBSP, the user would be able to navigate to that directory and delete the associated file or copy them off. So, as I've been talking, I'll give a quick walkthrough demo. So here, we have a pre and post USB infection. I have a drive F, its name is REcon 2023. That would be typically the manufacturer's name. And here you see on the root of that drive, you see these folders, some files, and it looks like they want to have a good time in Montreal attending the REcon conference. Post-infection, this is what the drive looks like. So after running the malware or the POC that I created, this is what it does. So again, if you notice, on the root now, we just have something that appears as a drive, but it's actually a shortcut because the type says shortcut, but it has the image of a drive, and it says REcon 2023, or whatever the volume name of that USB device is. And if you look at the properties of that, you can see it's running x32 debug. Now, if you were to go into the NBSP directories, what this thing is doing, every time you click that shortcut, it's calling explorer.exe and passing in the path of the NBSP to bring up the files that were in that second NBSP folder. So to the user, when they click that, they see their files, all is good. And if you notice here are all the files, but if you notice there's something called recycler with the r.bin direct folder. It says file folder. But if you were to click it, it would take you to recycle bin. And can you spot the NBSP here? Again, not very obvious, it's right there. So we're too deep off the root of the USB device. So if I were to change into that recycler bin via Windows Explorer, it's not showing that files directory. It's not showing x32 debug. It's because it's linking back to the master machine's recycle bin. So you'll never see those underlying files. And NBSP makes visibility hard because you see that F is there. Now, I know that there's a files directory. You might be like, Mike, files directory is there. If I were to add that files to the end of the Windows Explorer, and this is what I get. You cannot change into that directory, but we know it's there. So I take that USB device and I mount it in, say, a forensics tool such as WinHex. It lets me see the raw underlying contents of this USB device. Clearly, there's a files folder here. Now, if you notice, there's a desktop.ini, which I mentioned earlier. And if you look, that class ID is there. That is the one to the recycle bin. So that's turning that recycler bin folder into a recycle bin so you don't see these underlying files. Pretty cool trick. And if I were to take that same USB device and take it over to Ubuntu and mount it, obviously there's no recycle bin on Ubuntu, and it has no problems traversing the NBSP folders and the recycler bin. Clearly see that the files do exist on this USB device. I do have a little video demo here of this behavior. Let's see if I can get it to work. Yeah. So here to the right is that same setup. Here to the left is a POC that I created, and I'm just going to run it, and it's going to launch calc to show that it works. And as you can see, I'm just going to close calc. All the files are there. It showed the files there. Now, if I were to go back to that, I see there's just a shortcut now. If I were to look at the properties of that, all it's doing is launching calc.exe that I placed on target. Running it does the same behaviors, but to the left it showed the files so the user would see. Now what's important here is by default, and this is what I explained to Microsoft, Windows Explorer, it doesn't show hidden files, it's not enabled. I'm just enabling it here so you can see the underlying NBSP directories, and you see that first one at the top. It's there, but it has the image of a drive. If we see to the right, its type does say folder. If I were to change into it, there's another shortcut there. Again, does the same behaviors if I click it. And if I were to go into the second NBSP folder, I see all the files, and now I see that recycler bin. Now I know calc is in there, but if I were to go in there, it's a link back to the master. I happen to delete a file, desktop.ini. So any files that are deleted would show up in here. Again, I cannot navigate to that directory in File Explorer, command.exe, or any other tool on Windows. Go back to this. So I took everything and I submitted it to Microsoft. I said, hey, Microsoft, well, I did say, hey, Microsoft. This is exactly what I sent them. Hey, Microsoft, we're seeing in the wild exploitation of this technique in this plugx malware. But most importantly, I'm concerned. I don't know if Windows Defender is actually able to scan the files in the files folder, because if Explorer can't access it, can Windows Defender access it? Microsoft assured me that they can. I've done some tests and it does. So that was about the beginning of January of this year. I notified them. Palo Alto Networks has a lot of telemetry, so we were seeing active exploitation of this particular technique. So we wanted to make sure Windows could put some protections in place to help the end user. In their response, they looked into it. Thank you. It took them 2 to 3 weeks to get back to me. There's no opportunities to improve the design. I was kind of bummed. I was just like, okay, I'll go with our team and see what we can do to put protections in place for our customers. But I really felt that Microsoft could do something to detect this, right? Well, something did happen. I was making the slides for this talk, running all my tests, and lo and behold, my VM updated. Windows Defender has new definition files. All of a sudden, Defender hit on my link file. As you can see there's the F:/REcon 23 link. I was like, huh, alert level severe. So this tells me that the Windows Defender team, with their telemetry, is actually seeing this in the wild. And they gave it some name, Trojan, Bat, Chit, Exa. I'm probably butchering that. I don't know where they came up with the name. If you were to Google that, you will see no reference to any of the link files, no reference to NBSP, no reference to plugx, or me for disclosing it to them. But I'm happy they did something. They put protections in place. So now we have a name. So then I went back to one of our favorite tools, VirusTotal. I was like, let's see what's out in VirusTotal. Here we see 6 samples submitted to VT. Still low detection. All those files are link file shortcuts. And you can see, maybe you can't see, the most recent one was uploaded last month, May 4th. So we're still seeing active exploitation of this particular sample. Now, I did discover a second variant of this. It has all the same capabilities, but one addition to it. Additionally, in that files folder, they'll create another folder called DA5202E5. I'm not sure why the name, but when they run it, they will exfiltrate all the host Microsoft Office and Adobe documents to that directory. This, to me, implies that somebody has physical access to the USB device. Think about it, if you walked into a secured office or anywhere, you plugged it in, you run it, copied all the Office documents, you walk out, somebody looks at the drive via Windows Explorer. If they have a Windows operating system, good chance they do, they're not going to see the files that they just copied off. And here's an example of that file existing. So again, it still shows that it's out there, it's evolving, but at least Microsoft now is detecting those link files. So future research that I was, for the audience, maybe you find this interesting, test other AV vendors. Can they scan those folders? Remember, it's a recycle bin. It links to the recycle bin, so it's not a folder per se. Can I create the recycle bin on non-USB devices? Possibly using this technique with COM. What other Unicode characters can be abused to conceal folders? Many COM objects out there that can be used for the desktop.ini entries, and there's little to no research on how a recycle bin folder works, and maybe another chapter in Windows internals. I think it would be great. I did some research on it, and there's just very little out there. So I think learning, for me at least, is by doing. I've repurposed this entire technique that I talked about today in this malware. I'm going to make it available at that address right there. After I'm done with this talk, you guys can download all the source code. It will produce this link file for you. So you red teamers out there, if you want to, create some USB device that launches Cobalt Strike or one of your tools of choice, you could do that. Oh, in addition, because you're all here today, I have a USB device. You can just come see me, plug it in, and you'll have this whole talk for you. It's up to you. Only if you have Windows, though. So thank you, and if you have any questions, feel free to ask away. Gotta have some questions, feedback. This is a novel technique, so if you want to get into the weeds of like why Windows does this behavior, I encourage you to explore it. When I first came across it, research is a bitch, I'll tell you that. You have the data, and you follow the data, and you have your heart. And in your heart, you want this data to be something, so you go down these rabbit holes, and you're like, I want it to produce this. This is so cool. I'm going to talk about it. And you're like, oh, this is kind of lame. But because that's what the data tells you. So I noticed in my research, I was always failing because I have to go with what the data is telling me, even though I wanted a different outcome. I was like, how is this working? Why can't I get to that files directory? What is going on with Windows Explorer? So I spent months actually doing this research, studying this particular sample, just because of the Windows components of it. Whoever created this, very interesting. And again, everything that I talked about today is actually being used in the wild. Threat actors are using this. I don't know why they're attacking a USB device, but they are. And this is just one component of it.
I think in the description of the talk, you mentioned that this is formable.
Yes.
What's the
Because every time, here I'm just launching calc, right? There, every time they would run it, they would infect the host in any other device. So every time it would self-propagate to any of the other USB devices out there, right? So I could totally turn this into a worm. Every time you click it, you're not knowing it's being executed. I can run any code I want. And we've seen that. So it seeks out every USB device attached to the host, the type 2. And this particular plugx checks to see where it's running from and behaves different. So if it's running from a USB device, it does these behaviors. If it's running from the host, it does these behaviors. Questions, comments? I'm sorry? Yeah, so you cannot, even if you know the path and you go to command.exe and you try to change into it, like CD, Alt 160 to get your NBSP, you can't change into it. File Explorer cannot access it, Command Console cannot, it's a combination of NBSP and turning it into recycler bin that File Explorer cannot access it. So basically the only way to get rid of that is either you change the shortcut, because you can see the executable there, or you format the device, or you mount it in Linux, or you have to know it's there. It's a product of how File Explorer and command.exe are accessing it. Yeah. Sorry? Can you ask it one more time so I got it right? Right. The question basically, is it a product of the OS or is it a product of the File Explorer or in command.exe? In talking with Microsoft and doing my own testing, I saw it as a product as File Explorer and command.exe, not being able to access it. Because you can code up code to access it. Obviously, create process is being able to access it, right? So, but it's a product of File Explorer itself. Because it's being executed from the NBSP directory and the recycler bin, so. Yeah.
Have you tried to navigate to this file with Windows 365 Linux?
The W, no, I have not. That's a good question. Go ahead.
So you said this was around 2008, which is pretty much also around the time that Windows XP was still relevant. Have you encountered any samples that have used R1 APIs?
No, I have not. I was just saying that the plugx sample itself, the lineage of the malware has been around since 2008. This is just one of the other capabilities that they happen to add to it to continue to gain persistence targets. I saw OLE32 DLL being used, some COM, and I was just like, what are they doing? And I really wanted to understand how this worked. Plus, they're using targeting x64 debug, and it was kind of personal for me. Any other questions? Thank you.